All right, let's talk about circles. Circles do weird things in isometric. Here is a circle, right? Here is a roll of tape, or a soda can, or a roll of paper towels, or a hole, or some cylindrical feature. So the point is, a circle is only round when you're looking directly at it. When you start tipping it up at 30 degrees, you see the circle is no longer circular looking. Now it is elliptical, right? And depending on where the tip happens, what direction, what face we're working on, we're going to have different ellipses. So what we're going to do is, I made a cube here, and there should be enough room on your isometric graph paper. If you make a cube that is 8 by 8 or 10 by 10, no bigger than 10 by 10 though, but make sure it's a cube and all the sides are the same size. All right, and again, I started out with a chicken foot and went up 10 and over 10 and over 10 and created my 3 surfaces for the front, top, and side. Okay, and now what's the idea? Well, the idea is this hole that we drill a round hole, but it doesn't look round in isometric. I mean, take a look at it. If you drilled a round hole, or drew a round hole in isometric, man, that looks messed up, or it should look messed up, okay? The circle is not round when it is tipped. It should be elliptical. So let's make believe that never happened. And let's get a retry, shall we? The secret to understanding how to make this is you have to know a little bit of vocabulary about ellipses. And an ellipse has 2 measurements. Okay, it's got a center point typically, but it also has 2 measurements. And one measurement goes from the end through the center to the other end. And this is called the long axis. And it's got another dimension, or another measurement, that goes across through the center to the other side. This is called the short axis. Okay, so the ellipse has a long axis at its longest point and a short axis at its shortest point. Now, keep that in mind, because I want you to look at these surfaces that we made. See, they all look like diamonds, don't they? Here is a diamond, here is a diamond, and here is a diamond. And the way to get things to line up correctly is look at the diamond and look at the long axis of the diamond. So look, this diamond, well, it's long this way, it's shorter this way. If you don't believe me, measure it, or use your dividers to check it, right? So if you can keep that in mind, just remember that the long axis of your ellipse will follow the long axis of the diamond on a cube in that surface. What does that mean? Well, it means quite simply that if we had to draw an ellipse, and the hole that we drilled is in the top surface, well, the long axis of this ellipse follows the long axis of this diamond. Okay? So think about it. Here's a round hole, and we tip it up. Doesn't the long axis go left to right? And here it does, go up left to right. Now, anything drilled in a top surface will have an ellipse that goes long ways left to right. How about the front surface? Would that ellipse look good over here? You know that we can't just use the circle, so let's take a look. See, that doesn't match, right? If I want to match what's there, I'd have to hold my hole at the same orientation as that front face. So which way is my ellipse pointing now? Isn't the long axis of my ellipse pointing up to the left? Just like the long axis of this diamond is up to the left? And it is. So my circle that turns into an ellipse is elliptical, but it is long ways, long axis, matching the long axis of this diamond, or this rhombus. Okay. Top, front. Top surfaces, long axis left to right. Front surfaces, long axis up to the left. How about right face? Well, look at the diamond. Do you see the long axis of the diamond, of the rhombus here? So that's going to tell us that the long axis of our ellipse should follow. And when it does, even though this is just sketched, we get the idea that these holes are in the right orientation for a part that had a hole drilled in this face, or that face. Okay, so it's the same ellipse, it's just pointed in a different direction depending on what face it's on. So let's apply this to a part. Here's the part. Okay, to make that part, we've got to make a block. So let's make a block. And we'll give it depth and height and width. And then we'll change that into surfaces. Okay, and I've kind of penciled in a light center mark to show where the center of that hole would be. So now can you imagine what shape ellipse I need, or what orientation ellipse I need to drill a hole through the front of this thing? We're going to work with A, we're going to work with B, we're going to work with C. Well, if we are on a front face, we work with A. So really lightly, I've sketched out a square in isometric, right? And here is the rhombus with its long axis. So I know my ellipse should go and follow that long axis up to the left, since it's on a front. Now, would you see any of the back of that hole? Good question, right? Well, same idea. How far back did you go? 1, 2, 3, 4. If I go back 4, I can figure out where the back of the hole is. I will make another ellipse that follows and fits inside that long axis. And it looks like, you might just see a little bit of sliver there. You could go and check the depth here with your dividers or your compass, and then from here and see how much of that you'd actually see. Okay, and there probably is a little bit, and the thinner it is, well, the more you'd see. If this was only 2 squares thick, there would be much more of that ellipse showing back here. Okay, but I will erase what I don't need now that we have the basic idea about how to lay out circles and holes in isometric. Most of the time for things that we draw, we're probably going to be talking about holes. We just have to remember which orientation to put the ellipse in when we are placing them. Now, drawing ellipses, obviously you can't do it with a compass. So how do you make perfect ellipses? Well, the answer is there are ellipse templates. One didn't come with your toolkit because for 1 or 2 assignments it seems rather silly to buy a $4 or $5 ellipse template for a couple of assignments. So we leave that out, but just understand if you had to draw isometric circles or ellipses like this, that they do make templates so that you can line things up and then go in after things are lined up with your center marks and then get perfect, precise ellipses every time. So after we have reviewed all of our information and we've done our isometric drawing practice by doing some sketching, we have a chance now to take care of our assignments. Okay, so looking through the course pack, you might want to take a look and just brush up on everything we've talked about so far. Always good to review the information. That's why it's in there. the second part of this assignment, once we've drawn it in oblique, down here, we're going to use this as our guide and use this for measurements or proper size to draw it in isometric. So this bottom corner here, a little chicken foot, well, that is going to be where you start drawing from. Your width will go this way, your depth will go this way, your height will go this way. Again, please match the heights and the widths and the depths that are here. Right? That's why this multi-view drawing is here. It's to give you some information about the shape, but also the sizes. So you'll be constructing an isometric drawing starting off down here that shows that object. Since your oblique drawing is complete, the next step will be turn that multi-view drawing into an isometric drawing. So we see the little chicken foot, our starting point. That will represent the bottom right corner of the figure. And we will go to the left to create width. We'll go up to create height, and we'll go back to create depth, right? So from here, width, height, and depth. Then we turn it into a box, and once the box is finished, we go back in, we add our details. In this case, you have to cut out a little channel through the whole part. A little room under the stairs here. And there's also a slope. Now I know it says the slope is 45 degrees. Just keep in mind the way we do slopes in isometric is we don't really care about degrees, we care about two things. We care about where is this point here and where is this point here. Right? We're going to find the linear distance from here to here and the linear distance from here to here and draw that out in isometric, and then wherever those 2 points are, we'll just connect the dots to make that angle. All right, so that is assignment 4.1 and 4.2. Assignment 4.3 is just a little bit more isometric drawing. Now 4.3, the top one is a little bit different from everything else we've done up to this point, and here's why. Look at the shape. See, the shape is not the front view, the shape is the top view. Okay, so when you are laying this out, keep in mind that this corner, right, if this is the width, and this is the height, and this is the depth, well, that's the starting point for the width going this way, the depth going that way, and the height going this way. But the shape will not happen in the front view, the shape happens on the top view. So you'll be working on the shape, and the shape will be visible from the top, not from the front or from the right side. This drawing is especially fun and painful because it's asking you to do two different things. This is a very complicated shape. It's actually two shapes superimposed on top of each other. So how does it work? Well, just do this. Figure out what your width is, your height, and then your depth. Then set up your isometric from that point with the proper width, the proper depth, and the proper height. When you've got that set up, you're going to draw the top view shape, this triangle, on the top view. And then try to create the prism that would make, because from the top it does look like a triangular prism. Now what's a little weird is from the side it looks like a box with a chamfer. Right? So what do? Well, on the front plane, figure out where the angle is, right? How far over, how far up to make the angle. And then once you've got the angle, cross over the prism. So you have to really make two different shapes and superimpose one on top of the other to find the solution to this. Okay, so this is tricky. If you have a hard time, let's talk about it. Drawing 4.4 and 4.5, there is a heavy piece of paper in the back of the course pack with the drawing assignments. They are numbered, they are titled, they have a starting point. And on each sheet, the starting point's a little bit different, so just be aware of that. You can't switch them back and forth. They have to have the right sheet for the right assignment. Okay, and what you need to do is you need to go back to the class pack to see the assignment. So here's assignment 4.4, drawing 4.4, uses this sheet, uses that starting point. So this thing is called a shifter stop. And basically what we're trying to do is take this multi-view drawing and turn it into an isometric drawing. So a couple things you'll probably take note of. First thing, all the measurements here are in fractions. Okay, second thing, it's a kind of a weird shape. Right? From the top, it's got a weird shape. From the front, it's got a weird shape. So this isn't one of these exercises that we've been doing where it's all in the front. There is some in the front, but there's also something going on in the top here. So work that out. And I would say the best thing you can do is figure it out on graph paper. Don't tape that piece of paper down and then try to figure out what you want. You're going to go crazy and you're going to make a mess. So go get yourself some isometric graph paper and then print it out. Look at what you're trying to create. Try to sketch this thing out in isometric before you commit to drawing on the piece of paper with the tools, right? And if you have questions about whether or not you're right, I'd be happy to answer your question, okay? But you want to have firmly in mind what you're trying to draw before you start drawing it, okay? Same thing for drawing 4.5. It's got its own drawing sheet. It's got its own starting point back in the class pack. If we go to page 4-10, we see the assignment. And again, I'm giving you a multi-view drawing. I'm giving you a 3-view drawing. And I'm saying, hey, turn this into an isometric drawing. So once again, we're working with common fractions. And again, this is not going to be done simply by drawing one shape on the front plane. If you look at it, there is a shape in the front. It's kind of like a trapezoid, right? So you got this tapering trapezoid in the front. But look, in the top, there's also this shape. It's kind of like an upside down U. So again, we're going to have to work this shape with that shape in order to get our solution. And if it's tough, you're having a hard time, you're not sure if you're right, well then let's contact me. Let's talk about it. Let's make sure that you're on the right track before you start drawing with the tools and then waste time and energy on something that's not right. We see too in the course pack that page 4-11 and 4-12 have been set up with some isometric graph on them for you to do a little bit of figuring out if you want to sketch out these problems or sketch out other problems until you are comfortable with your solution before you start drawing things out by using the instruments.